In this lesson, we shall focus on mathematics, Euclidean geometry for grades 11 and 12. We shall look at similarity and proportionality. We shall prove two most of the important theorems on similarity and proportionality and Euclidean geometry in general. Right, I want us to recap on this particular theorem. Okay, there are two important theorems that you are rest assured you will actually obviously apply in the diagram below. Triangle KLM and triangle GHI are drawn such that the angle K is G, the angle L is H, and the angle M is I. Prove the theorem, which states that if two triangles are equiangular, then the corresponding sides are in proportion, right? That is proof that KL over GH equals KM over GI. Let's get started with the proof. Now, to actually prove this here, we actually begin with what we call the construction. We begin with the construction. On sides, right, on sides KL and KM of the triangle KLM, what you need to do is to mark points. Right, you mark points A and B, right, on KM, L and KM of the triangle KLM. Right, what you need to do is to consider those particular triangles, the particular triangle KLM, and also note that on the sides KL and KM, mark points A and B respectively. Right, respectively. With this said, such that KA is GH, KA is GH, and KB is GL. Draw AB. Right, so what we then do here, we mark off A here with B. Call this one A1. Let us write down the proof. Right, in writing the proof, we know that in triangle GHI, in triangle GHI, and triangle KAB, we make the following observations, that KA is equal to GH, KA is equal to GH, and right, so let's just move further down. Right, we also make the observation that the angle K is equal to the angle G. The angle K equals the angle G. Right, okay, now we need to put a couple of reasons here. So KA is equal to GH because of a construction. The angle K equals the angle G, and this is given. KB is GI. Right, KB is GI. construction. And with this mentioned, we are able to take note at this point of the fact that we're able to take note of the fact that the triangle GHI is congruent to the triangle KAB. This is true because of the side angle side. In other words, side angle side. Next. Right, so, but now I want to also note that the side KB equals GL, KB equals GI equals GI. Right, okay, B equals GI. Like so. Right, so, okay, with this mentioned, we note that we have made that construction, we called this AB, and we actually marked this off like this. Therefore, the angle A1 is equal to the angle A1 is equal to the angle H. But the angle L is equal to the angle H. Why is the angle L equals the angle H? Given the angle A1 equals the angle L. Yes, please.
So why are you saying A1 is equal to H? Is it because you prove that they're congruent?
Yes, because we showed that this triangle here and these are congruent triangles. Because there are two congruent triangles, it means therefore the corresponding angles are equal. Okay, corresponding to the sides, because this side equals this and this equals that. That is the reason why you then have to say that the A1 equals actually A1 is H to start with. So A1 is H, but we know that L is equal to H, and therefore it means that A1 is L, right? So it means therefore that the angle A1 is L. Okay, let us take a look at this one. Therefore, AB, because if this angle equals this, if the A1 is L, these are like corresponding angles. So therefore, AB is parallel to LM. Corresponding angles equal. Now the KL over KA is KM over KB. Right, so KL over KA is equal to KM over KB. Why? The reason for this is line parallel one side. Line parallel one side. Right, one side of triangle. Line parallel one side of triangle. Therefore, okay, let's check this one. Therefore, KL over GH, KM over GI, KL over GH is KM over GI. Okay, this is a very important theorem. They'll often ask you to prove one of these theorems. Either they ask you to prove this theorem, which says in the diagram below, the triangles, the triangle KLM and triangle GHI are drawn such that the triangles are equiangular. Right, prove the theorem which states that if two triangles are equiangular, then the corresponding sides are in proportion. So now you need to be able to remember this theorem, but also you must be able to do the correct construction. You must be able to do the correct construction so that you can succeed in this case. Right, so we move forward. We move forward. Okay, we'll recap on this proportionality theorem. We'll recap on the prop theorem. Right. Right. Okay, let us look at this prop theorem. So it's very important that you are able to prove this theorem. We've just proven this one, but also you must be able to prove this one because by and large, one of them will be there. One of them will be there. And so, right, in the diagram, triangle A, or rather ABC is a triangle. So we have ABC is a triangle. D and E are points on sides AB and AC. Right, you're able to see that. Respectively, such that DE is parallel to BC. So line parallel to one side of triangle. This line parallel to one side of a triangle has the power, has the ability to divide the other two sides in the same proportion. Right, so we're good. And we actually remind each other on how to prove this result here, and we perform the most needed construction. The most needed construction. Okay, I'm proving these two theorems because they are sort of the chief theorems. What you need to do is to actually join BE and CD and draw H1 from E perpendicular to AD and H2 from D perpendicular to AE. Let us write the proof. Right, to write the proof, we know that area triangle ADE divided by area triangle BDE. Right, so now, okay, let us first perform the construction. Right, so let us join BE and also CD. So we join BD, but also CD as shown. But simultaneously, you draw H1 from E. Perpendicular to AD. And H2 from D. Perpendicular to AE. Like so. So that you have half AD multiplied by H1 divided by half BD. Okay, if you look at the area of the triangle ADE, sticking on the AD side, you'd have that the area is half base by height. Half base by height. So it's half AD, the height H1. Now, if you look at the triangle BDE, BDE, it's half base BD times the height H1. AD over BD. Area triangle. Yes, please.
Why is it H1 for BT?
Okay, why is it H1 for BD? It is H1 for BD because the triangle BD, you can see that is a triangle like this, with B here, D there, E there, and then the height is like this. Right, so a height is always perpendicular to the base. Okay, so the height is not inside the triangle, yes, but it is the height of the triangle BDE. Right, because it is from the base, which is BD, to the apex of the triangle, which is the point E. So that the area, triangle ADE over, the area triangle ADE over area of triangle DEC. Right, so now if you look at the triangle ADE focusing on the AE side, you're going to say half AE multiplied by the height. So AE, the height is H2. The base is EC. The height is H2, giving us AE over EC, because H2 cancels in that. Okay, now if you get the triangle ADE focusing on the AE side, we know that is half the base AE, the height H2. Right, moreover, the EC is half EC, the height H2, and therefore H2 cancels and the half cancels. Okay. The area. The area triangle ADE is equal to area triangle ADE. Okay, so ADE is on top and it's also on top. So the area of triangle ADE is equal to the area of triangle ADE. Why? Because it is common. Because it is common. But area triangle BDE is equal to area triangle DEC. Same base. Same base and height. All right, with the understanding that, at this point, what we have here is the following. With the understanding that what we have here is the following, DE is parallel to BC. So the area of triangle BDE at the bottom is equal to the area of triangle DEC. Therefore, area triangle ADE, area triangle BDE area triangle ADE divided by area triangle DEC Okay, because now we have already said that the ADE area is the same. The BDE, DEC area is the same. Why is the area of triangle BDE equal to the area of triangle DEC? It's because they have the same base, DE, and also because they have the same base and height. Why? Because they lie between the same parallel lines. Therefore, they have the same base, and in particular, they have the same base and height. Okay, the height is the same because of the parallel lines there. Okay, therefore, AD over BD is actually equal to, so now we have that AD over BD, but you can write it the same way, like AD over DB. AD over DB is equal to AE over EC, like that. Okay, so now think about this and make sure you understand this proof. Make sure you understand this proof. So that we proved the two theorems. We proved this one on the fact that if two triangles are equiangular, if two triangles have equal angles, then the corresponding sides are in proportion. That is, as stated there, that KL over GH is KM over GI. In the diagram, we have that ABC is a triangle, D and E are points. D and E are points on sides AB and AC, respectively, such that this DE is parallel to BC. Right, use the diagram above to prove the theorem, which states that a line drawn parallel to one side of a triangle divides the other two sides proportionally. That is, we have to prove, therefore, that AD over DB is AE over EC. Any question? Any question?
No, sir.
No question. We move forward. Okay, we have this one. In the diagram below, right, triangle PQR is an equilateral triangle. PQR is an equilateral triangle inscribed in a circle. V is a point on the circle. Now, QP produced meets RV produced at T. T is there. PR and QV intersect at W. There is W over there. Proof giving reasons that W1, right, yes, W1, this one here, is actually equal to the angle TRQ. 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 Like this. Okay, now we have some reasoning to do together. We have some gymnastics to do. Right. What is the first step? What is the first step? Right. What do you think? We're not rushing. We are not rushing. You need to prove giving reasons that W1 is equal to TRQ. Right. What do you think? What do you think? Is it too easy? Right, we're trying 10.2.1. Okay, in the diagram, triangle PQR is an equilateral triangle. Now, by equilateral triangle, it means what? Now, with the PQR, you have the interior angles are equal to each other. 60 degrees. 60 degrees. 60 degrees. $60 degrees, 60 degrees, 60 degrees. Now the 60 degrees is this one here. Because the triangle PQR is equilateral. Because it is equilateral, we have that. So in 10.2.1, we first note that the angle R1, right, right. So what we have now here is that the angle R1 is equal to 60 degrees. Equilateral triangle. So we know that the angle R1 here, it's 60 degrees because we have an equilateral triangle. Moreover, we have the angle W1. Right, so the angle W1 is equal to the angle P1 plus the angle Q1. So the angle W1 is equal to the angle P1 plus the angle Q1 because of this. Great tan. So the angle W1 is equal to P1 plus the angle Q1, exterior angle of triangle. What is the angle P1? Right, we can see that indeed the angle P1 is equal to 60 degrees. Plus the angle Q1. But 60 degrees is equal to the angle R1 plus the angle Q1. So now this means we're saying effectively the angle W1 is actually equal to what? It's equal to R1. Right, angle W1 is equal to R1 plus Q1. Moreover, we note that the angle Q1, the angle Q1 is equal to the angle R2. Q1 is R2, and these are angles in the same segment. Angles in the same segment. Therefore, the angle W1, therefore the angle W1, now if you look at the angle TRQ, the angle TRQ is R1, R2. So the W1 here is R1, the Q1 is R2, and this therefore means that W1 is now R1 plus R2 is TRQ. TRQ. Exactly this way. Any question? So we have proven, therefore, that the angle W1 is actually equal to the angle TRQ. Any question?
No, sir.
No question. Move forward to the next one. Move forward to 10.2.2. In 10.2.2, proof giving reasons that the triangle TQR is similar to triangle QRW. TQR like this is QRW. QRW. Okay. So now this is way too easy. Way too easy. What do you think we need to do here? What do you think we need to do here?
So I think we can. I'm not sure. We need to find like equal sides, equal angles. We know that R1 is equals to, I think we said 60, right?
Yeah.
So we can say I think T will also be 60. I'm not sure, sir.
Okay, now let's start when you're doing things like this, you need to specify the triangles in which you're working. So in triangle, TQR in triangle.
So did we find the value of Q1 plus Q2?
That's a good question. Did we find the value of Q1 plus Q2? Well, we know the value of Q1 plus Q2 because PQR is the triangle PQR is equilateral. So if PQR is equilateral, it means that each of the angles is 60. This one is 60, Q1 and Q2 is 60. P1 is 60, but also this one is also what? 60, because the triangle PQR is equilateral.
Okay, sir.
Yeah. So in other words, now in triangle TQR and triangle Q. Okay. Now we want to prove in these two triangles here. Right. Want to prove in these two triangles here. Want to deal with these triangles here. But also want to prove that the triangle TQR is similar to triangle Q. Right. QRW. Right. QRW. So now let us first work in a couple of these triangles. Okay, we shall review just now. But if you actually now are dealing with a triangle TQR and also the triangle QRW. Let's take QRW. Let's take QRW for now. Okay. And then we shall see what happens. Right. So now, if you look at the TQR and the QRW, the angle W1 right, the angle W1. The angle W1 is equal to the angle TRQ. Right, the angle W1 is equal to the angle TRQ. Okay, why is W1 equals TRQ? This one has been proved. Proved in 10.2.1 above. The angle R1 is actually equal to the angle 2TQR. Right, the angle R1 is equal to the angle TQR. Why is this the case? Because R1 is 60 degrees, but also TQR is 60 degrees. So that if you look at what is happening in the angle QRW, so in other words, because of the equilateral triangle. Okay, we first took the fact that the angle W1 is TRQ. The angle R1 is also, the angle R1 is also TQR, or it is TQR, whereas the other one is TRQ. Now, I want us to mention something. Then you have remaining angles now, because you dealt with W1, which is TRQ, this. And then R1, this one, is actually equal to TQR, this one. So now you have one more angle left in the triangle QRW. QRW. We have already dealt with W1. We have already dealt with the angle R1. So we're left with the angle Q2. Right, we're left with the angle Q2, and it must be equal to the remaining angle. Also in the triangle TQR, we're left with the angle T. And this is the sum. Sum angles of triangle. Sum angles of triangle. Therefore, the triangle. Okay, let us write everything in order. Let us write everything in order. So now if we start with the triangle TQR, it will therefore be similar to triangle. Now T is equal to Q. So we note that T equals Q. So now we note that in the triangle TQR, the angle T equals Q. Moreover, the angle in TQR, the angle Q is equal to the angle R. And the angle R is equal to W. Angle, angle, angle. So now the triangle TQR is similar to the triangle QRW. Any question? Any
No,
question?
sir.
Okay, no question. We move forward. So in the next question, 10.2.3, we are saying that PT over QW is PV over WR. It's PT over QW. It's PV over WR. Okay, I'm giving you 2 minutes. 2 minutes to prove this one on similarity and proportionality, and then we shall do the corrections now. 2 minutes.
Sir, can you please do this one together? Because I have questions and I don't really understand this type of theorem.
Are you done?
No, so I was saying, can you please do this together? Because I wanted some clarity on something.
All right, that's fine.
How do I find like proportions specific?
Proportions, yes. Okay,
Yeah,
that's fine. That is okay. All right, let's get started with it. But I don't want you to feel bored and sleepy when everything becomes too obvious. Okay, first thing, like the way you saw how we started the proof on the fact that these two triangles are similar, when you prove proportionality, you need to start with the triangles. So in which triangle? So you need to study the diagram carefully. Okay, now we are looking at PT. You must go to the diagram and say PT. Okay, it's a side like this. And then now you note, for instance, that there's PT, then there's PV. There's PT, then there's what? There's PV. Ordinarily, the top sides come from the same triangle. Why? The top sides come from the same triangle. Why? I want to show something here. Okay, I want to show something here. So if you look at this theorem where everything started in mathematics, KL, KM, which are the top sides, they come from the same triangle. The bottom, GH, GI, they come from a different triangle. So the top sides will often come from one triangle and the bottom sides will come from the same triangle. Okay, it is enough to allow us to say, based on the Equiangularity theorem, the top sides are actually from one side. So we have the PT here and the PV. And then it might suggest that we have that triangle there. So we can then say in triangle TPV, for instance, in triangle TPV. Okay, and now we look at the bottom sides. These ones, they all normally come from the same triangle like you saw in the Equiangularity theorem. So now you have to identify QW. QW and WR. That tells you are dealing with triangle WQR. Triangle WQR. First. So we have identified the triangles in which we shall work. Now it remains to show that these two triangles, now to prove this, we must show that the two triangles are equiangular. Right. Now, first things first, we know that the angle PQR. The angle PQR is the angle R1. The angle PQR, this one here, is the same as the angle R1. Why? Because this triangle is what? They're both equal to 60 degrees. Both equal to 60 degrees. Okay, because the triangle PQR is isosceles. Yes, please.
So in order to prove the equiangular theorem, we have to prove that the angles are equal to each other.
Yes, yes. Because it is from the theorem that says that if the two triangles are equiangular, then the corresponding sides are in the same proportion. So now,
Okay.
here we need to prove that the corresponding sides are in the same proportion. So to prove that corresponding sides are in the same proportion, we prove that first we must establish that the triangles are equiangular. Now, we have seen that from what the examiner wants us to prove here, everything is coming from the triangles here, TPV and WQR. Okay. The angle PQR, for instance, is equal to the angle V1. The angle PQR is equal to the angle V1. Why? Exterior angle of a cyclic quad. Exterior angle of a cyclic quad. Because the exterior angle of a cyclic quad is equal to the interior opposite. And by dint of this, you can make a lot of observations that also this angle here is 60 degrees by itself. Number 2, yes, please.
So I don't have to read in the statement that the shape is cyclic quad. I can just like look at it and say that it's cyclic quad. They don't have to say anything. Like I don't have to prove that it's a cyclic quad in order to use it. A cyclic
Well,
quad. Even though they
okay,
didn't say
okay.
it in the statement.
Well, because you see, the thing is that here it is a cyclic quad. The cyclic quad is this one, is the blue one. Okay.
Yes, I can
Yeah.
see it, but I was afraid. Like in the exam, normally
Yes.
like I get afraid to use a shape. Like I know what a cyclic quad is. There's like a
Yes.
shape that has all its vertices on like the
The
circumference
circumference of a circle. Yes.
of a circle. I
Yes.
understand that,
Yes.
but then sometimes bef-
Sometimes it is,
before
yeah.
before you even answer the question, they ask you to prove whether it's a cyclic quad or not. So sometimes I'm even afraid of even
I understand. I understand. Okay, look,
with that.
they can never ask you to prove that it is a cyclic quad if already the four sides are the four vertices are on the circumference of the circle.
Oh,
This
okay.
one is not worth proving.
Oh,
So the only time we prove is when there's no circle around it. Then we need to prove. But like in this case, this one is already the four vertices are already on the circumference of the what? Already on the circumference of the circle. It is automatically a cyclic quad. So that we cannot prove, we can just use. But however, if it has four vertices, a shape with four vertices, but there's no circle around it, then that one we don't know if it is like a quad or not. Yeah, but in this case, the V1 is an exterior angle because 1, 2, 3, 4 are on the circumference of the circle, all those four vertices. Right, let's move on. In number 2, The angle P2 is equal to the angle TRQ. The angle P2 is equal to the angle TRQ. Why? Exterior. Exterior angle of a cyclic quad. Exterior angle of a cyclic quad. But the angle W1, okay, let's just remove some of these things here, because this is just so untidy. Okay, let us continue with this. But we have already said that the angle P2 is equal to the angle TRQ. Why would this be the case? Because again, we have the exterior angle of a cyclic quad. But W1 is already TRQ angle. W1 is TRQ. This one is TRQ because it was proved in 10.2.1 above. All right. The angle P2 is equal to the angle W1. Because you can even use therefore here. P2 is TRQ, W1 is TRQ, therefore P2 is equal to W1, meaning that P2 is W1. But also this is this and it's that. Number 3, the angle T is equal to the angle Q2. Yeah, the angle T is equal to the angle Q2. Which is the sum of angles of triangle. Sum of angles of triangle. Therefore, the triangle. So we are back to these particular triangles here. Right, if you take the triangle TPV, it is similar because now, look, we have said that the angle, because we're dealing with the triangle TPV, and the triangle WQR. WQR. Like this. Okay? And we have noted equality of the angles, like we have seen that the angle V1 is equal to what? We noted that the angle V1, for example, WQR and TPV. Right, we made a couple of observations that the angle T, for instance, is equal to the angle what? It's equal to the angle Q2, yeah? But also we made the observation that the angle P2, this one, right, is equal to what? It's equal to W1, for example. And then we have the last one, which is the angle V1. The angle V1 is equal to the remaining angle here, which is the angle R1. Angle R1. So in particular, I wanted us to, should have stated this here. If PQR is R1, PQR is V1, the conclusion then becomes, that the angle V1 is the angle R1, right? So the angle V1 is equal to the angle R1, like that. Okay, now let us see this. So now the triangle TPV is therefore similar to the triangle what? T. T is equal to Q. P. Right, and then P is equal to W. And then V is exactly R. Why? Angle, angle, angle. Angle, angle, angle. Okay. Now, at this point, we are excited to make the following conclusion. We are excited to make the following conclusion. You see, by dint of what we have proven now, we're able to take the first two with the first two. The first and the last, the first and the last. This one, that one. So you then say TP over QW. TP over QW, it's TV over QR. PV over WR. So now, this is exactly what we have. By dint of that, then you can come here and then say, therefore, now this one is TP, you can write this what? As PT by symmetry. And this one is QW. And this one is equal to, so you take the first one and then you take the last one. The last one is PV over WR. What's the question? Any question?
No, sir.
Okay, this is an example of a similarity and proportionality sort of result.
Yes, sir.
Yeah, it was quite an interesting one. I'm sure you have learned a thing or two. I'm sure you have learned a thing or two. I'm sure you have learned a thing or two. Right, we continue. We continue. Okay, we'll move on to the next one. The next one is yours and me, but I want to see what you think. Right, in the diagram below, the circle with center O is drawn. OQ is drawn parallel to a tangent. OQ is drawn parallel to a tangent to the circle at D. At D, you have a tangent. ER is drawn with S on OQ. S on OQ. RD is produced to P. RD is produced to P, and PQ is joined. Right, and PQ is joined. RD is produced to P, and PQ is joined. Okay, right. So if they say, for example, RD is produced to P, it means this one is a straight line. It's a straight line. Okay. But moreover, I've been given that PE is X units. PE is X units. PQ is X plus 9. PQ is X plus 9. PD is 2/3 of X. PD is 2/3 of X. And also DO is X plus 3. DO is X plus 3. Calculate the length of RO. Calculate the length of RO. This one here. I'm giving you 2 minutes. I know it's easy, but let me give you some good 2 minutes. Let me give you some 2 minutes. All right. Right. What do you think?
So
Yes, I'm testing you.
I'm not sure about how you use, because I know here we're gonna have to use, it's either we use like proportions to find a certain side. That's how I'm looking at it. That's, I don't know how to find that.
Okay, that's fine.
Because I can see that QE is gonna be 9. That's the only thing that I can find. But the rest I know that for, if I want to find like RO, for example, I'm probably gonna have to use like the actual length of something to find something. I don't know.
I understand. Never mind. But what do you know? What is O? Point O. Is it any point or is what?
O is the center.
O is the center of the circle.
Yes, sir. Oh, and it's the radius.
And it's a radius.
So RO is gonna be equal to x plus 3.
So RO
Am I
is
right?
X plus 3. So now,
Yes, sir.
what is the first thing you need to observe? That this DO is a radius. And this is a radius. So that it is X plus what? So this RO is X plus 3.
So I thought maybe when I read the question, I thought they were looking for like the actual length.
Yes, they're looking for the actual length. But that is what you can observe immediately, but they're looking for the actual length as a number. So what can we do? What can we do here? Right. What can we do?
So I'm not sure. I was thinking maybe
Yes.
I was thinking maybe we find the actual length of DO and then it will be the actual length of RO. I'm
Okay,
I'm
never
not
mind.
sure.
Never mind. You know, it's too easy, this question. because you're just going to use we already have parallel lines, this one. So because now they wanted RO, they were just teasing you, but in fact, they want DO because they're already equal. So you can just, but you need to just find DO here. But DO is in a very nice triangle in which you already have what? Parallel lines like this. So because of that, then everything is obvious. So you can take PE, for example, over EQ. You can take PE over EQ. It must be equal to PD over.
So can you please explain the parallel theorem, what it states, so that I can know when exactly and how to use it?
Okay, here's the parallel theorem. Here's the parallel theorem.
Yes, like what?
Okay, yeah. So now, if we have DE parallel to BC, then it means that AD over DB is equal to AE over EC, because you already have these sides parallel. Yes, please. Okay, please come again. Please come again. Please come again.
So, so I didn't catch that. My audio, my Wi-Fi is unstable. So I was saying, if we say two sides are in proportion, it doesn't necessarily mean that they're equal.
Yes, it doesn't mean they are equal.
So then, what does it exactly mean?
Well, if they're in proportion, it therefore means that you have that these particular two the proportions are equal, meaning that the same proportion means that AD over DB is equal to AE over EC. So in other words, use the diagram above to prove the theorem which states that a line drawn parallel to one side of a triangle divides the other two sides proportionally. So this is parallel to this, it divides the other two sides what? Proportionally. That is AD over DB, it's AE over EC. You get the point? So a line parallel to one side of a triangle divides the other two sides proportionally, or divides the other two sides in the same proportion. So the other two sides are such that they're divided in the same proportion. Obviously, doesn't mean that there's anything that is equal here, except that the AD over DB is equal to AE over EC. Okay, we are using that, and then we're coming with that theorem, and obviously we just prove the theorem, and then we come here. Here, the examiner wanted you to just find DO. That is all. But because you already know that this is like the theorem we just proved there, this is already parallel to this. Because of this, then you can just say, okay, PE over EQ is equal to PD over DO. Right. So we continue.
So,
Right. Yes, please.
so how do I find the actual length for any side here?
Okay, that is what, so we need to use this particular proportion. And because this is the same proportion, this line is parallel to another, one side of a triangle divides the other two sides in the same what? Proportion. And then you come and then say line parallel one side. One side, triangle POQ, or you can say that the prop, in the exam, you just say prop theorem. You just say prop theorem, ED parallel to OQ, like this. What is PE? Okay, let me just remove this so that you can see everything very well. Just 1 second. Line parallel one side of triangle POQ, or if you don't want to say this, you say that the prop theorem, right, the prop theorem, ED parallel to OQ. Okay, you can say we're using the proportionality theorem. Why? Once you say PE over EQ is PD over DO, you can just say prop theorem. Why? Because line parallel one side of triangle POQ. Right, line parallel one side of triangle POQ. Or you can say proportionality theorem because ED, right, proportionality theorem, ED is parallel to OQ. What is PE? PE is X. What is EQ? Like you said, it's going to be 9 because this whole thing is X plus 9. So this one is 9. PD. What is PD? PD is 2 out of 3X. DO. DO is what? Is X plus 3. And then now you cross multiply, which is X, then X plus 3, which is equal to 9, 2 over 3X. 9, 2 over 3X. Right, so that in the end, X times X squared, 3X. Now, 3 goes how many times into 9? 3 times, and 3 times 2 is 6X. And this is exactly X squared. 3X minus 6X is minus 3X equals 0. X minus 3 equals 0. This means that X is 0 or X is 3. X is 0 is not applicable. At this point, we know, therefore, that DO is equal to X plus 3. But X is 3. So that we have 3 plus 3, which is equal to 6 units. Like we said that. But DO is equal to OR, and these are radii. Therefore, because you have already found DO. Instead of the examiner saying find DO, the examiner wanted us to then say, therefore OR is 6 units. Therefore OR is what? Is 6 units. Any question?
So, you know
Yes.
how with proportions we normally apply x to the actual length, or am I?
Yes.
So like with this one for DO, can't I just remove x and then say it's positive 3?
Please come again. You're saying we can't just remove X.
Yes, because because like what I learned is that with proportions, it's just the actual length with the x.
Okay, like in terms of like saying the RO is X plus 3.
Yes, sir. Can't we just remove the x and say it's
Oh,
3?
okay. Can we just remove the X and say it's 3?
Yes.
You mean like here?
Yes, sir. Because we just add an x to
Okay,
the
okay,
actual length.
okay,
I don't
okay,
know if
okay. Yes, okay. Yeah, I hear you. Yes, there are times when we actually, but these are actual lengths, These are what? These were actual lengths. The X was an actual length. It was not just a proportionality variable. And the PQ was X plus 9. So these were like actual lengths. This was 2 over 3 X units. They were not just proportionality variables, you know?
so how do I tell the difference between a proportionality variable
And the
and
actual
an actual
length.
length? Like an actual length has units, but then a proportionality variable doesn't.
Yes, a proportionality variable doesn't have units. Right. So your
Okay.
proportionality variable doesn't have what units. And how do you see a proportionality variable? It's when the examiner says, they would say, for instance, PE to EQ. Okay, what is PE, for instance? Okay, here, PE is X, right? I want to give you an example. So here, PE is X, and X is what? Is 3. So PE is 3. And then what is EQ? EQ is 9. Okay, so that this one you can divide, you can simplify these. 3 over 9 can be written as what? 1 to 3. So when the examiner gives it as PE to EQ is 1. Okay, yeah. So the examiner gives it as that.
Then so when we add it onto the graph, we just say 1 8.
Yes, because yeah, the examiner can give it as PE to EQ is equal to what? Is equal to 1 is to 3, for example. You get the point?
Yes, sir. So sir, when I
So
calculate the actual,
this one, it's not an actual length. It's you need to introduce some proportionality variable here.
so with this one, how do I calculate actual length?
Yeah, with this one to calculate the actual length, like we know that DO has the actual length X plus 3 because they
No,
say
sir.
it's X plus 3 units.
I was saying with the proportionality
Oh,
ratios.
the proportionality ratios. How do you get the
Yes, sir.
actual length? Well, the proportionality ratios, like if they say it's 1 is to 3, 1 is to 3, you'll have to write it as the 1 over 3. And then you multiply it by x, you multiply it by x so that it becomes like maybe x over 3x, like that. So that would mean, for instance, you can then come and then say, if it is PE, so here PE would have to be x. And EQ would have to be what? 3x, for example. You know, if it is given in terms of a ratio, then these are not actual lengths. So now you need to introduce some proportionality variables. And then say PE is 1 unit is X. And then EQ is some 3X. All right. Okay, we're gonna see a problem like that today. If I'm not mistaken, I have questions like that. Okay.
Yes, sir.
Right, good.
Thank
We
you.
move on. The next one we shall discuss together. Okay, now you know everything. You know what the X is. You know that X is 3. But the examiner says if OS is 1,4 units, OS is 1,4 units, and S is the midpoint of ER. S is the midpoint of ER. Determine the length of DE. This one. Determine the length of what? Of DE. This one.
So, sir, if you found that x is equals to 3, does that mean wherever I see x here, I can substitute 3?
Yes. Yes.
Okay.
It means that you know this one is already X is 3. This one is, you put 3 here. It's going to be 2 out of 3 times 3, which is what? 2. So this is like 2 units. This DO is 6. 6. This one is going to be what? It's going to be X plus 9, which is 3 plus 9. What is 3 plus 9? 12. You get the point? Something like that. So because we know. But now the examiner is saying if OS is 1.4 units, OS is 1.4 units, and S is the midpoint of ER, determine the length of DE. Determine the length of DE. Determine the length of DE. What do you think? What do you think?
Triangle RDE is a right angle triangle. And then you use like ratios. I'm not sure.
How do you know it's a right angle triangle?
Because it says I don't know, but the shape of it looked like a right angle triangle to me. So
Okay, yeah, I get your point, but it would have been quite right angled if ever if ever there was an angle subtended by diameter. If ever there was an angle subtended by what? By
diameter.
diameter. Then we're going to be sure. I mean, it might be, but we don't know quite because
We
no
can't
one told
see.
us, you know?
Yes, sir.
Right. So we don't know yet. So we have no confidence of saying that. But you see, this one is the diameter. So this diameter would subtend an angle of 90 degrees if ever this was here, but this is outside. Then we're going to know that this one is 90 degrees.
But
But
sir, you know
yeah,
that DE is a tangent. So it doesn't that mean that the tan chord theorem applies here? Therefore, that angle there by DE is like a 90-degree angle.
oh yeah, this one, yes.
Yes.
Okay.
So
Now you are
then,
making a point. So this one is 90 degrees, yeah?
so sir, then we
Because
can find.
it is tangent perpendicular to diameter, yeah?
Yes, sir. But then I think my main problem as well would be finding, because I was gonna look for the length of ER. I don't know why. If I
Okay,
need to find the
okay.
length of ER in order to
Yes,
calculate.
yes, okay. What do they want here? What do they want? They're saying OS is 1.4 units, right? OS is 1.4 units. And S is the midpoint of ER. S is the midpoint of ER. They're testing you here. Here they are putting the answer in front of you. They're taking you back to grade 10. Is the proportionality theorem for the midpoints. Once they tell you about the midpoints, sometimes they don't tell you about the midpoints, but you already know O is the center, and therefore O is the midpoint of this of the chord. So also it is the midpoint here, but they even told you S is the midpoint. And this one is called the midpoint theorem. What is the midpoint theorem? Midpoint theorem.
So the midpoint theorem, doesn't it state that it split like how you drew here, it splits it's like the midpoint of a line splits the
Yes,
line
yes,
into
yes, it has to do with the midpoint of that. So if we have 1.4 here, then because this one becomes 2 times this one. This one becomes 2 times the short one. The longer side becomes 2 times that one. You know, so now you
So
then
which one
say
becomes which side becomes 2 times of what?
this longer one, this one is longer than this one.
Mm-hmm.
So this longer one is actually 2 times the short one. In other words, if this one is A, B, C, D, E, then you can say that BC is 2 times DE.
So, but then they only said that is the midpoint of.
Yes, they only said that
Oh,
this is,
okay, okay, I see it.
yes. So they wanted to make sure that you have midpoints like both sides. You have a midpoint here and a midpoint there. Because we already know that O is the midpoint. How do we know? O is the midpoint of this DR. Because it's the center. So it's the radius and radius. So the examiner wanted to make sure that also S is the midpoint. Because if ever you have the midpoints here like this, so we're saying a line segment joining the midpoints of 2 sides of a triangle is parallel to the third side, but it is also equal to half the third side. So alternatively in grade 10, you were taught that this DE is half BC. You know, it's called the midpoint theorem from grade 10. But you must have a midpoint here and a midpoint there, midpoint here and a midpoint there. So how do we use it now here? Here they've already said this one, determine the length of this DE. They're taking you back to grade 10 because they're saying this one is 1.4. If this one is 1.4, now they're saying find this one. So you already know that this smaller one, if you multiply the smaller one by 2, you get the longer one. So you then say S is the midpoint. S is the midpoint of RE. Why? It was given that way, that S is the midpoint. From grade 10, we then say that this DE, from grade 10, we then say that DE is double. DE is double OS. Why? Because of the midpoint theorem. When do we say midpoint theorem? When you have the midpoint this side and another midpoint the other side. Midpoint this side and another midpoint. It doesn't mean that this must be equal to this. No, it's just midpoint on the left and midpoint on the right. So that now DE is twice OS, which is the midpoint theorem. Midpoint what? Theorem. So DE is twice OS. So that DE is the OS. What is the OS? OS you already know. So now this DE is longer than this one. So this DE is 2 times the small one. So it's 2 times 1,4. And what is 2 times 1,4? It is 2,8 units, which is exactly what they wanted here. They said determine the length of DE, and DE is 2,8 units. Any question?
No, sir. I
Okay,
understand, sir.
okay, that's fine. I'm trying to make sure I give you a chance to try the questions. I'm trying to make sure I give you a chance to try the questions. So we move on. Let us try the next question. 11.3. If the triangle PED, the area, right? So here they said the area. See here? The area of triangle PED is 2,7 units squared. Okay, so if the area of triangle PED is 2,7 square units, find the area of, okay, let's check, PED. The area of triangle PED, so this one here, is 2,7 square units. Find the area of PER. PER.
Sir,
Yes?
is it because they have parallel lines? Does that mean that they are congruent?
That's an interesting question because of these parallel lines.
Yes, because
Yeah. Okay, now if you look at PER, it's bigger than PED.
so they're similar.
Then you can speak about similarity. Yeah, you
Sorry.
can speak about similarity. But to speak about similarity, then you must prove that they're equiangular.
Oh, okay.
You must prove that they're what? They're equiangular.
Equiangular.
Area. Area, okay, this is how we can do this one. It's easy. 11.3. Area of triangle PED divided by area. Triangle PER. What is the area of triangle PED? Okay, the area of triangle PED, right, because you already can see that this angle is 90 degrees and this angle is what? Is 90 degrees. So this one is sort of a height and that is sort of a height. So you can come here and then say the area of this triangle is half base. What base would you take? You can take, for instance, PD times the height. What is the height? Which is exactly ED divided by half. Now, if you look at the triangle PER, it has a base. It has a base. The base is what? Is PR times the height. The height is the perpendicular height, which is what? Which is still ED. Okay, using the half base by height formula, we're able to therefore see that this half cancels, the ED cancels, and then you have PD over PR. So what we already know the length here. So what is PD, for example? PD is this one, but X is already 3, which means it is this one, 2X out of 3, which is 2, 3, 3, which is what? Which is 2. So this PD is actually what? 2. Then what is PR? PR, it's everything here. This one is 6. This one is already what? 6. This one is 2. So 6 plus 6 is 12. Plus 2 is what? Is 14. So if you divide these things here, it's 1 out of 7. In other words, this is saying the area, triangle PED over area, triangle PER is actually 1:7 ratio. 1:7. You cross multiply here. Want to find the area of triangle PER, so you cross multiply so that area, triangle PER, area of triangle PR, it's 7 times the area of triangle PED. Area, triangle PER. What is the area of triangle PED? It's 2,7. And therefore, if you multiply everything, let's use a calculator here. Let us use a calculator. Seven times 2.7. 18,9. 18.9. So this will actually become what? 18.9. 18.9 units squared. 18.9 units squared. Any question? So we're to find the area of PR. In the area of PR, we got it to be what? 18,9 square units. What did we do? Okay, it was a little, slightly tricky question. Slightly tricky question, but you have to realize that, okay, you actually have been given that of PED and you need the area of triangle PR, and you could be like, okay, the area of PED you already know, and then the area of PR, you can just form the ratios like this. You can just form the ratios. And the ratio of the area of PED to the area of PR, then you're able to get the answer. You're able to get the answer. Any question?
No, sir.
Okay, some little tests. These are tests. I test you. Here's the time when you are given the ratios. And you are not given the length here, but you're given the ratios. This was in one of the prelims. Potentially, yeah, one of the prelims, one of the Gauteng prelim exams. Okay, so now let's look at this one. It was in the prelim exams and it's similarity and proportionality. But here you're not given the lengths exactly, but you're just given some ratios. And then you might need to use the proportionality variable. In the diagram below, triangle TPQ is drawn. TPQ is drawn. PQ and US. TP and US are produced to meet at what? To meet at R. Okay, yeah. So you're able to see that. Now the question is, okay, UR and TQ intersect in S. UR and TQ intersect in S. SU is parallel to QV. S2 is parallel to QV. TU, the ratio of TU to UP. TU over UP is equal to 2 out of 5. And 3QS, 3QS is 2 times ST. calculate giving reasons the ratio of PQ to QR. Okay, this one I'm giving it to you. 5 marks. I'm giving it to you.
So can we please do this one together?
Okay, that's fine. Okay, but sometimes I enjoy giving it to you because I want to see what you can do.
So do
Because
the next one. I just want to understand this.
yes, that's fine. Yes.
I'm looking at it and I don't understand how I'm gonna start it in the first
Okay,
place.
that's fine. That's fine. Okay, that's okay. So we're gonna do this one together, okay? Because I always make sure that I give you a chance because I'm not greedy. I'm not stingy. So um okay, yeah, we are here, but I'm giving you like a minute to read and then we shall do the corrections together just now. Okay, because and then we shall move to another one. Right. Okay, yeah. Yeah. Yes. Yes. I know that maybe you're anxious, right? You are anxious. Okay, now let's look at this question together. So now we can just use the proportionality theorem because in this case, we need to actually take note of a couple of things. What should we take note of? Let us use the proportionality theorem because we want to find PQ, the ratio of PQ to QR. But if you look very carefully, the ratio of PQ to QR right, so we need to write down what we got. We use the proportionality theorem all the way. The ratio of PQ to QR. Okay. So, okay, we continue. Okay, we continue. Okay, yeah. Okay, yeah, sorry. Right, welcome, Anika. We are concluding our discussion here. We're concluding our discussion here, so please just stick around. Right, we're concluding our discussion. Okay, I was saying now here as we're concluding our discussion, calculate giving reasons the ratio of PQ to QR. I was then saying if you look at the PQ to QR by the proportionality theorem, because you already have that this here is parallel to this. And so you have this triangle here. You have this triangle here. Right, so, I mean, having this triangle reminds you of the proportionality theorem. Right, the proportionality theorem. And with that, then if you have a line segment that is parallel to one side of a triangle, then it divides the other two sides in the same proportion. Meaning that we have the PQ, for example, over QR, it must be equal to what? It must be equal to PV over what? PV over VU. And this, in the exam, you just write that one, and you just say it's the prop theorem. You just say it's the prop theorem. Okay, but obviously, they said calculate giving reasons the ratio of PQ to QR, but by the prop theorem, okay, you don't only write prop theorem, of course, you write the sides that are parallel, right? You say prop theorem and then state that, for instance, your RU, right, your RU is parallel to QV, like that. So you continue. We continue. So now, okay, what do we need here? So if you look at this question very carefully, this is what we need. So even in the exam, you can just write that in the exam. They're saying calculate giving reasons the ratio of PQ to QR. So you need to say PQ over QR. It's PV over VU. And then you write here prop theorem, proportionality theorem, because RU is parallel to QV. Like that. Okay, this one came in one of the prelims. One of the prelims by Gauteng. Very likely 2019, 2018. Okay, one of those years. I took it from that question paper. Okay, now, when you get here, you realize that, you know what? What do we know? Right, you will need, for instance, PV. You will need PV. But do you know PV? We don't know PV. So we'll have to find PV. Do we know, for instance, VU? Right, we know VU. Well, we don't know VU, so we'll have to find VU. Okay, let us find everything we need. We just need PV, VU, and then off we go. But now we need to come here and then say, the examiner gave you some of the things here. Like they told you that TU to UP. TU to UP. Right, this TU is 2x. The UP is 5x. Okay, so now you know that. But also the examiner gives you this. When they give you this one you can write as QS over ST is equal to 2 over 3. Right, so that when you're dealing with QS over ST, now the QS, you can call it 2y, the ST, you can call it 3y like this. Okay, so now, with this mentioned, okay, these are not actual lengths. Right, so now, these are just proportions. So what do you then say? Okay, we're going to start by saying, for instance, QS over, okay, in view of this given information, so QS over ST would be equal to VU over UT. Why? Okay, let's check. If you have QS over ST, it's VU over UT. And this is the prop theorem. Right. It's the prop theorem, proportionality theorem, because you know that at this point, when you say, for instance, QS over ST is VU over UT, it's because of what? It's because of RU parallel to QV. Can say that. Right. RU parallel to QV. Okay. What is QS over ST. QS over ST is 2/3. VU, what is UT? Right, what is UT? Right. So now, if you look very carefully, you'd realize that your UT in this particular question is exactly what? There it is. There it is. So the TU. So now this one here, you can write it as a 2x. When this one here, the 2 and the 3, you can call them y. Right, so you can call this one, for instance, the QS, you can call it 2y. The ST, you can call it 3y. And then the UT, which is TU, you can call it 2x. Like that. Meaning that you can be able to get VU. What is VU? So that VU, the 2 cancels. So that VU is going to be 2x times 2. The y cancels here. So 2x times 2 is like 4x out of 3. Okay, the y cancels. So it's 4x out of 3. Now, with this mentioned, you got actually the VU, which is what we need in the denominator. That is what we need in the denominator. So note the VU. We're finishing, please. Okay. And then we just need to find PV. You just need to find PV from here to there. But you already got this one. So now we are in business. We're going to write in this color, in the blue color. So now you can then say you need PV. So you can say PV is equal to what? Now, PV is the whole 5x minus what? Is the whole 5x minus 4x out of 3. Okay, what is 5 minus that? 5x minus 4x out of 3. So now here you say 3 by 5, 15. 15 minus 4 is what? 11 out of 3. 11x out of 3. Like this. Okay, we're done. So this one is the proportionality. This one here is the proportionality theorem. We are finishing, please. We are finishing, please, Anika. It's our last thing. It's our last problem we're doing with the young star. Okay, so now this is the proportionality theorem. And then now, okay, I want to remove this and write the final line for this. So now, okay, take a look at this. Okay, we've already got PV, which is 11x over 3. We've already got VU, which is 4x out of 3, so that we are able to write the following conclusion. All right, so now we need the PQ over, according to this one, PQ over QR is equal to what? What is PQ? It's PV over VU. PV over VU. What is PV? 11 over 3x divided by, what is VU? Is this one, which is actually exactly 4x out of 3. Right, now the x cancels, the third cancels, giving us exactly 11 out of 4. Check this out. And that is the answer. So to find PQ over QR, it is 11 out of 4. Any question here Naledi?
No, sir.
No question. I'm gonna give you a
Yes, sir.
homework. Can I give you a small little homework? Okay.
Yes, sir.
Right. Okay. So this one you saw how it had to be done. I wanted to give it to you first to try, but you suggested we do it together. So I'm gonna give you another question. Here's another one. Right. So this one is your home activity. Right. So this one is your home activity. Okay, just read quickly and then we close. All right. Right. In the diagram, PQRS is a quadrilateral. Right. You have PQRS is a quadrilateral. It's not a cyclic quad. We don't know if it is a cyclic quad. It might be if we prove. Right. With diagonals PR and QS. Okay. Now, W is a point on PS. Okay. You can see W there on PS. WT is parallel to PQ. Okay. Once they give you the parallel lines, you know you have the proportionality theorem coming into play with T on QS. Okay. WV is parallel to PR with V on RS. You can see V on RS. TV is drawn. Right. So somebody draws TV. TV. All right. Here, these are not actual lengths. These are not actual lengths. This is actually, these are proportions. So now this tells you that here you have equal proportions. So now PW, the ratio of PW to WS. Right, so you come here and you take PW to WS is actually 3:2. Write down the value of the following. Wow, okay, just need to write down, not a lot of reasoning. ST over TQ, SV over VR. Okay, so you try this one, it's your home activity. Yeah, it has a lot of other questions that follow. But I'm giving you this as a homework. You think about it, and yeah, I'm sure you can do this with so much ease. But it's very similar to the question that came in the prelim paper. Right, I think that it was awesome having this discussion right now. Until next time, take care
Yes, sir.
and have a
Thank you,
good
sir.
one. Okay, thanks, Dan,
Yes,
and
sir.
goodbye.